Welcome back. This is video 4 on data structure. We will see here how a simple linked list can be created in C from scratch. Also, how to add a new node at the end of a list. In the previous video, we saw that there are 3 steps to create linked list. And there are 3 pointers that are required. The start pointer and the mnew pointer hold the addresses of the first node and the new node respectively. The temp pointer can traverse over the entire list, starting from the first node like this. Now let's write a program for this in C. First, we define the structure of node. We give the name node itself to the structure of the node. X is a member of int type. Since the data part is not of much concern, we keep it as a simple int variable. We have the next pointer within each node. Notice the data type here. It is struct node start type. Why? Because this pointer will hold the address of a node. The other 3 pointers will also be of struct node start type. Now the main starts here, and we take 3 pointers, start, mnew and temp, and all of them are of struct node start type, right? Next, we initialize these to null. Now you see the visualization. The start pointer is pointing to null, mnew is also pointing to null, and temp is also pointing to null. Now, to allocate memory during runtime, we will use an inbuilt function named malloc. Why runtime allocation? Because creation of nodes for building the list should be done when the program is in execution, right? That means when the program will be running at that time, the nodes will be created in memory. So memory allocation is a runtime thing in this program. For that reason, we need malloc. This function, malloc, takes an integer as an argument. Now this integer will be treated as bytes. For example, if 8 is passed, then 8 bytes of memory will be allocated for you. And this will happen during runtime. Now, what will be the value to this malloc for allocating a node? Means, what is the size of a node here? You see, there are 2 members in the node structure, and sizes of these members are machine dependent. Means, in some machines this int x will carry 2 bytes, and in some machines this int x will be allocated 4 bytes. So, we do not specifically know the size of this struct node. Then what to do? It's better to take the help of the sizeof operator here. the sizeof operator will compute the size of this node based on the machine. Remember, it's a unary operator and not a function, though it looks like a function. Okay? Well, provide the data type of the memory allocation you need over here, because sizeof will ask you about the data type. So our data type is struct node because we want the size of this node. So we pass this struct node as an operand to this sizeof operator. So what you see, the sizeof operator do the calculation of the size of this struct node, and that will be an integer value. So ultimately this malloc function is getting an integer value over here as an argument, right? Since this allocation is during runtime, we are unable to provide a name to it, right? But it has an address, more specifically starting address of this allocation. Then a pointer can help us to access this location. Let mnew do the job. So mnew will take care of this allocated memory here. But this will not work. Why? Remember the property of a pointer. What it says, the data type of a pointer and the data type of the location it points to must be similar. But here what we see, malloc is void star type. So the data type of the area that has been allocated by malloc is of void star. And on the other side, the data type of mnew is struct node star. So it is not matching. So that is why mnew cannot access this allocated memory by malloc. Then what to do? You write struct node star in front of malloc. This is actually called typecasting. So you typecast the allocated memory to struct node star so that this allocated memory has been upgraded from void star to struct node star. Now this mnew's data type and the allocated memory's data type match. Now mnew can access this allocated memory now. So we create a node and we just write this code over here. I hope it's clear until now. You may pause the video for a moment to make this whole thing clear to you. Well, let's proceed. Now our node has been created at 743 with the data part nothing inside and the address part nothing inside. So our first step is over, creating a node. The next one is loading the data and setting the address part of the new node to null. So how to load the data is simple. You load x with 11 like this. Now we have used here the arrow pointer here. Why? Because this mnew is a pointer and it tries to access the X, which is a member of the struct node. So to access a member of a structure using a pointer, we use this arrow operator. Now if this mnew is a general variable, it's a conventional variable, not a pointer, then you can use the dot operator here. Okay, so that is not relevant now. Okay. So the next pointer, which is a second member of the structure node, has been set to null. So it will look like this. So the second step is over. Now we go for the third step. Insert new node in the list. To do this, we have three situations. First, the list is empty. Now, how will the program know that the list is empty? You see this visualization. New node is there, ready to be inserted. But start is pointing to null. Now think of this. If at least one node would have been present in the list, the start pointer would have pointed to the first node, right? That means start would not be null if there is at least one node in the list. But here you see that the start pointer is pointing to null. That means there is not a single node here inside the list. So we write like this. If start double equal to null, then the mnew will be the first node. So we write start equal to mnew. So now start will hold the address 743 here. Now the second condition, list has only one node. How will you know that the list has only one node? So let's see this figure. You see, this mnew is holding the new address that is ready to be inserted, and start is holding the first node in the list. You also notice that the start next pointer is null. That means there is no second node here in the list. So this proves that there is only one node in the list. So you write like this, else if start itself is not equal to null and start next is null, then this mnew, this new node, will be the second node in the list, right? So you have to connect these two nodes by changing the null pointer here with 291, right? So you write like this, start next equal to mnew, because mnew is having the address 291 and you store this 291 inside starts next. So it will look like this. So it is 291. And if you place this 291 over here, these two nodes gets linked. Now this is the third and last condition. List has two or more nodes. That means list may have 2, 3, 4, 5, 6, 7, any number of nodes there. And since this is the third and last condition, so we can put this thing in the else part. Okay. Now let's say this visualization. We have 4 nodes here. Now this is the example which is having 4 nodes. Actually, it may have 5 nodes, it may have 2 nodes, it may have any number of nodes there. So we should generalize the logic here, okay, so that it can handle any number of nodes in the list, right? Now we have the start pointer here, which is having the 743. We also have the mnew here, which is having this 197. That is, this is the new node that is getting to be inserted in the list, right? And we have this temp pointer here, which is null. Now temp will have a role here in this condition. Now this node may be inserted at the end, or in between any nodes here, or at the front. For this example, we are going to place this new node at the end, so that this becomes the new last node. Okay. Now 2 or more nodes means the number of nodes in the list is unknown. So we have to find the last node, and then we will connect that with the new node. Okay. So from the figure, how will you identify the last node in this list? You have to find a unique feature which belongs to the last node only. And what is that? You see this next pointer here. So the next pointer in the last node is null. But in the other nodes, the next pointer is not null. That means it is carrying some data or some address, right? So we will use this logic to identify the last node. Now temp pointer comes into play. So set the temp pointer to the first node like this. Now what we want to do actually? Our plan is to move temp to each node one by one and check whether the next pointer there is null or not. Now if not, we move the temp to the next node and check it there. And if yes, we stop. And we will be sure that the temp is actually standing on the last node. Quite interesting, right? Write this, temp equal to start. That means temp is holding the address 7423 now. Okay. Now you run a while loop where you check whether this temp next is null or not. Now you see that at present the temp next is 478. That means it's not null. So you store this 478 inside temp. So you write like this, temp equal to temp arrow next. So when you write this, then the 478 has been copied to temp and the figure goes like this. The temp is now pointing to the second node here. Now you get back the loop and check again. The temp is now standing at 478 and its next is not null. So you get inside and do this job. That's temp equal to temp next. That means temp next is 521. So copy this 521 to temp and it goes like this. Now you get back and check again. Temp next is null or not. So you see here, temp next is 291. It's not null. So get inside and copy the temp next 291 to temp, and it becomes this. Now you get back and check again whether temp next is null or not. You see that temp next is null here. So the loop stops. So what to do? So to connect this new node with the last node, what do you have to do? You put this 197 here and place it right here in place of null. So this 197 is there with mnew. So if you write this, the temp next equal to mnew, that means this null will be replaced with 197 and your new node will be added as a last node in the list. So all the steps are over and we have created a linked list. Thus, we learned to create a simple linked list program and different logics behind it. In the next video, we will see how a node is inserted in the beginning of a list. Thank you for watching and take care.